What am I doing with all these LEDs? No, 4 LEDs is not a lot. This is a lot. In this video, I'm going over the build of 1 kilowatt LED lighting modules, of which I'm building 5 to provide high-intensity lighting for high-speed filming in the garage. Each module will consist of 10 of these LEDs mounted to a custom water block I'm going to machine. Here's a view of the water block itself in CAD. I designed it to be relatively easy to machine. It doesn't have too many fins in the water path, but that shouldn't be a major problem since water is such a good thermal conductor, or has such a good heat capacity. There'll be 2x10 on each, 2x5 on each block, and there'll be these lens holders and lenses mounted on them to collimate the light a little bit more effectively. I won't cover the machining too in depth here, but I'll just give you a quick overview and then a time lapse. So we're going to face the top off, cut the water channels into it, drill a few holes, drill and tap a few holes on this side so the cover can go on, and then we'll flip it around and drill and tap all of the holes for the LEDs and to mount the front cover that holds the lenses on. This is the longest operation. It's going to take about almost 20 minutes to do to cut the water channel. I could leave this unattended, but it looks like you're going to have to stay around to just blow the chips off of it to avoid them pointing at the end mill. Next is a whole bunch of spot drill and chamfers. Drilling the holes prior to tapping. Cross your fingers for no broken taps. First one worked well. Other side now. This is just a bunch of drilling and tapping. I've added some support to the wood block underneath because the chamfer mill, when it was doing the spot drilling, was actually deflecting and bending this down. This should solve the problem. That one's all done now. Now we need to do the back cover, which is much simpler, just a few operations on the back, just facing it off, then cutting a groove for the O-ring and drilling a few holes. These came out pretty well. There's a bit of problem with the finish on this corner where it was overhanging. I filed it down the best I could. We'll see if that holds with the as an O-ring sealing surface. This other one came out, I'd say, much better. Really nice surface finish. Now I've got to make a gasket, or an O-ring. I'm just going to use this O-ring, linear O-ring cord, cut it to the right length and glue it into an O-ring. I was worried that this O-ring cord was going to be really floppy and want to fall out of the groove, but it seems to be okay. After a little bit of, tiny bit of tension, it seems to hold just fine. Okay. The rubber place I got this from just suggested using super glue to attach this, so that's what I'm going to give a try. Not sure if it's going to hold very well, but if it doesn't work or it leaks, then we'll try something else. Now the question is how long you got to hold that for. Just want to rub off the excess on the outside so it doesn't impede the sealing ability. May have to put a dab of grease or something at that location just to make sure it doesn't leak out there, but we'll see. The O-ring groove on this is designed to squish the O-ring from down to about 80% of its relaxed thickness. So this 0.125 inch O-ring squishes down to 0.1 inch. And I designed the width of the slot so that when it squishes down, the squished width is the same as the width of the slot. So hopefully that will keep the compression, stop it from taking too much force to compress it. I found the squish of down to 80% is what I found in some literature for designing O-ring grooves like this. Oh, that's really nice. It doesn't fall out too easily. It's actually really nice. Okay, so clean. That one's clean. Ready to go together. Yeah, I've tapped these for 1/4 inch NPT, so we can put some standard fittings on there. And then there's 16 M4 screws that hold this all together. That should be able to generate enough clamping force. Okay, that seems to have clamped it all properly. Not a ridiculous amount of clamping force. Now, to mount the LEDs. Now they're going to be run 2 in series in groups like this, and I've done that because the forward voltage drop of the diodes varies with temperature. So what we want to try to do is maintain the average temperature of each series connected pair the same. So in this case, the inlet and outlet will get the hottest one and coldest one. As we go towards the loop, the turnaround, where the temperature is equal, that should result in the average temperature of each series pair being the same, which should result in the best current sharing. Because if we say if you had them in pairs like this, that in series and that in series and so on, you'd have the two hottest ones in series in parallel with the 2 coldest ones in series, and that would result in poor current sharing. The hottest one, the voltage would drop, so that would take more current. They get hotter and they take more current, they could get into thermal runaway. This design will hopefully avoid that. I should have mentioned this when I had this open, but the design of the 2 fins with the gaps in between them, as you see here, is to try to create some turbulence in the flow, because when the air or when the water flows by a warm surface, it'll heat up close to that surface, but the water farther away won't really heat up. So the idea is, after it goes over each set of fins, the fins basically stop and then restart, and this will hopefully create some turbulence that will mix the water up, so you don't get this stratification with the hot water sitting right next to the fin for the whole journey, not really cooling it very effectively, because we don't have super fine fins like they have in a lot of those PC coolers, because that's a lot of effort to make. You have to use a special, basically a special slitting saw that cuts many small slits, and I don't have that. It's kind of difficult to set up. So this we'll see how this does. This is not a particularly stressful application. We got about 70 watts of heat approximately being conducted out the back when the diode's running at 100 watts. When soldering on these wires, we've got to make sure that this joint is as flat as possible, because the lens comes down over here and is adjacent to this face, so it's got to be very close down. In terms of wiring, I'm just connecting the positive and negative inputs to these internal terminals, and obviously they're connected in series by the convenient junction in the center. And all the LEDs are wired up. Each 5 groups wired in parallel with some thin wires, and I've deliberately made all of the wires the same length so that the resistance to all of them is the same. And I'm using this relatively thin 22 gauge wire, hoping that adds a little bit of resistance that will help the current sharing between all the LEDs, because I haven't made any attempt to do voltage matching between these. If this ends up causing a problem, not having good enough current sharing, I'm going to have to take these all off and bin them by voltage, and then select them to put them in pairs that have that sum to a similar voltage. Got this plumbed into the water cooling components from the 2.5 watt argon laser. Let's fill this with water and see if it leaks. No drips so far. Power supply is all connected up, water cooling is running. Let's give this thing a run. I'll just slowly turn up the voltage here and we'll hopefully see the LEDs light up. 30 volts, shouldn't conduct until around 50 or 60. There we go. Oh, those are lighting really, really evenly, even this low current. I'm impressed how good the voltage, forward voltage matching is on these. That is 48 volts and nothing measurable. Let's bring it up. Let's bring it up to an amp. Ooh, that's really bright. Noticeable. One thing I noticed is these LEDs, even though they're advertised as 4,000 to 4,500K, seem to be a little bit on the warm side. I'm wondering if they're production rejects from a real 4,000 Kelvin batch and they're not quite meeting their spec. They do seem to be good quality though. They have big dies. They light evenly at low current, so I really can't complain. Okay, so there's an amp. How high are we? Not bad. And I hope to power these off of a few of these old battery chargers. I've got a decent collection I got from my old work from the junk bin. I can just modify these into power supplies. And they're good to about 60 volts. So if this stays under 60, we're golden. Okay, let's bring this up to, I'll leave it around 5 amps. See how warm are we getting. No detectable heating whatsoever so far. That is excellent. Yep, let's bring this up to 10. At full power is about 15, 16 amps. Let's try 10 amps. There's 10, hitting about 60 volts there. Should be pretty well within the capability of the supply. Oh, that is nice. That's really bright. Let's kill the room lights. Oh, no difference at all. Okay, temperature still absolutely cold. You can really feel the heat just from the light from those. Got no warmth whatsoever. I'll let that settle in, see what temperature it gets up to. I just turned this off when I noticed some smoke rising, and it turns out I think it was the table. The table was getting so hot it was starting to smoke just from the light. This is really, really powerful. Actually, I take back what I said about the color temperature. It seems that when you operate the LEDs at low power, the light is sort of yellower. I think it's, and then when you bring the power up to full, the white light becomes the proper 4,000 Kelvin that it should be. I think that's because the phosphors on the LED start saturating at higher power, so they put enough in so that when they saturate and the LEDs are at full power, they produce the proper color. So they do, if you run these at low current, they seem to produce a yellower light. This has been running for about half an hour now and all the temperatures have stabilized. I've measured the inlet water temperature at 31.8 and the water block just behind the LED at 37.5 degrees Celsius. So just about a 6 degree delta T between the water and the heatsink under the LED. That under LED temperature was measured right in this little hole with thermal paste, so that should be pretty accurate. Without lenses, about 3 meters in front of the light, we're getting about 6,200 lux. I'm at my friend's place. He has a really nice laser cutter. I'm going to cut out a wood cover for the front of the LED. We didn't quite get all the way through that the last time, so I just had to run the job again. So I'll have to turn up the power next time. these new covers fit absolutely perfectly. Let's give this a try and see how much this has increased the light intensity compared to the earlier measurement. There we go. Yep, that definitely looks more intense. Bit of a yellowish band on the outside. I'll have to look more into that, but let's see what intensity we get. Same position as before. 15,000 lux, so it was about 8,200 before, I think, so just about doubled. The intensity on this thing is just ridiculous. I'm almost burning my hand just holding it here in front of the light. The light is so intense. That's not the infrared heat like an incandescent would produce. This is just heat due to the pure intensity of the light, visible light. As a quick comparison, I've set the camera on manual exposure, and this is the intensity with the LEDs. Let's compare that to the intensity with the old 1 kilowatt metal halide I was using as a high-speed filming light previously. And here is the metal halide lamp. So at about this position we get about 7,000 lux from the metal halide, and the LEDs right here get about 10,000 lux. That's quite a bit farther away though, at a similar distance from the light about here. We're getting 20,000 lux. So yeah, these are way more efficient than that metal halide. Okay, I think that's pretty much all I can do for tonight. Next video I'll continue trying to solve that yellow ring around the edge problem. Also need to add some proper connectors, some thermal cutout switch, and then set up the water cooling system in the garage here. The radiator will probably be outside there, and the lights will be mounted up various locations around the ceiling. And of course I've got to make more of those water blocks. Anyway, hope you enjoyed this video. Thanks for watching.